Good morning. How are you? Okay, so today's topic we are going to discuss is refraction. Basics we are discussing here, like basics of object image, basics of reflection, basics of plane surface. This is not elaborated discussion. It will be done again when we will come here. Basic of refraction, that topic we are going to do. So if we will start with the basic definition of it, how to write the definition. What is the definition of refraction? Definition is very simple. Bending of light it is, right? Bending of light while traveling from one medium to another. One medium to another is called refraction. That is a daily life phenomena. We keep encountering this. It is called refraction. One of the example is shown here also. That is also a refraction example on. So refraction is a very simple thing, right? Bending of light when light travels from one medium. If I am drawing a diagram here for you, or we can see in this diagram also, when light has traveled in this particular diagram, okay, it is traveling like this, and here you can see the bending. At this point you see here it has bent, right? So when light travels from, suppose one medium is very denser medium, denser medium, and second medium is rarer medium, means denser, rare according to particles of those medium. Like we are moving through a crowded place, that is we are in denser medium, there our speed is little slow. And when we are moving in a rarer medium, our speed is fast. If we are driving something or we are moving, walking, that way it will be defined. So some medium is very denser medium, and light is traveling from denser medium to rare medium. Obviously in rare medium means speed of light is high, and denser medium means speed of light is less, decreases. So here the speed is more, so whatever path it was traveling, it will bend away from it, and that bending is called, we are not discussing cause as of now, just telling what is refraction. Whenever light going from one medium to another medium, it shows deviation from the path, and that deviation, that point is called refraction. Okay. Now my question to all of you, one question here I will ask, and very important concept also, listen. Do you know that who decides density for a wave? For a material it is mass by volume. For wave, a medium is denser or a medium is rarer, how we decide it? For sound wave, what medium is denser? For light wave, what medium is denser? For different of wave, what decides denser or rare? That's my question. Refractive index is for a light wave, refractive index is different concept, but okay. My question, have you heard, all of you? My question is very simple. Who decides for a wave, either sound wave or light wave, who decides that a particular medium is rare or denser? And the answer is not material, beta. Answer is speed. We will decide according to speed. Like one example I will take. See, suppose I am taking sound wave. Like I am speaking something and you are listening it, that sound wave speed is around 332 meter per second, and that medium I am taking air, right? But suppose I am taking metal, specifically iron I am taking, approximately that is 1500 meter per second. That is in iron. Speed of sound wave, and this speed of sound wave in iron is this. Where is the speed more? For sound wave, when we speak, that in very childhood you have studied on railway track, when we put our ear, from large distance train sound is coming, that is the metal there. In which medium higher speed is there? For sound wave, iron has 1500, air has 332, obviously 1500 is greater. So iron for sound wave will be rare medium, and air for this sound wave will be denser medium, right? So when you discuss about a wave, a particular medium for that wave is denser or rare, with a comparison we make on the basis of speed. For particle, generally I will say air is rare and iron is denser, but not for particle density. If I am asking that for wave, then you will decide this according to speed. Okay, that point you all of you understood. Who decides the density? So always don't think whatever looks denser to you may be rarer to wave. That is for sound wave. Iron looks denser to you, but it is rare for sound wave. So that is the refraction. How to decide a medium is denser or rare according to speed, that we have decided. Now the point is, obviously the next slide we will discuss what is the cause, and that answer you guys have to give me. What you think, what is the cause of refraction? But let me summarize the first slide to you first. In first slide, what discussion we made? Just summarizing. First I said, what is refraction? Bending of light while it traveling from one medium to another medium. Second, I told you that two medium are there. So one medium will be rare beta, one medium will be denser. How we will decide it is rare or denser? We will not see the particle density all the time. That is always decided by the speed. Speed decides rare or denser. In second slide, what is the cause? Speed. When from a source light is coming and on an interface, below interface denser medium is there. So it slows down. It slows down, and when it slows down, it will change its path, right? It will come here towards normal. This angle is I, Babu, that angle is R. This is the rarer medium, and that is the denser medium. What is the cause? Cause I am asking, cause is speed. Cause is speed, which is high, as I already discussed with you. High in what medium? Rarer medium. It means away from normal. And the same diagram is already drawn here. We can see when it is coming from medium 1 to medium 2. Can you tell me here which medium is denser and which medium is rare? By looking at the diagram, can we say which medium is denser and which medium is rare? So it is going here, striking here, and then bending. So it means that is denser medium, and that is what medium, Babu? Rare medium. Simple. Speed will be low for what medium? Speed will be low for denser medium. And this speed comparison, this will be towards the normal. And this speed comparison, we write this speed comparison of medium with one ratio, and that ratio is called refractive index. That ratio is called refractive index. So refractive index is a ratio. It doesn't have any unit or dimension. It's not a physical quantity, rather it's a ratio. Refractive index, and that refractive index, that is what? That is speed of light. Speed of light in vacuum upon speed of light in medium. So different medium will have different speed, and due to different speed, light will change its path, and that changing path phenomena is called refraction here. And this is mu, that is represented as mu, and that is equal to C by V. That is the basics of definition of refraction. Okay, in basic any doubt to anyone? Because I am going to ask you one question on that basis, on that definition. So before that question, do you have any doubt? No, sir. So I am asking you one question. Question is, calculate deviation produced by refraction. Light is changing its path. Obviously it is deviating. How much deviation it will produce? Okay, lateral deviation I am not asking, better. Simple. Angular, only deviation means angle. Lateral deviation means then you will tell me that displacement and all. Okay, simple question. See the path. that is incident ray. That incident ray is coming on that path, right? Had this medium not been changed, the same path light would have been traveled. This was the actual path of the light, but now light is going on this path, so it is deviated. That is the deviation. And that deviation is how much? If this angle is I, that total vertically opposite angle will be I. But out of this total angle I, this angle is R. So how much is deviation left? This much. That is total angle I minus total angle R. Angle of incidence minus angle of refraction is called deviation. Okay? Angle of incidence minus angle of deviation is called, angle of refraction is called deviation. On that I am asking one more question. Similar question I am asking, some of you have missed it, please do it now. That is the sphere, right? In this sphere, at certain point, light is striking with angle of incidence I and refracted with angle of incidence R. Okay? Now tell me deviation produced here. Deviation produced by the sphere. That sphere, how much deviation it is producing. Don't be hurricane in this question. Don't jump onto conclusion so quickly. Please have a thought process and then solve it. That is the sphere. That is a medium, obviously. Outside medium I am giving you as air. That is, let's say, glass. It is a denser medium. Light is striking it, refracting, and then it is going outside. Obviously, from denser to rare, it will go like this. Now tell me, what is the deviation produced? In this question, when my question is asking me deviation, deviation is between the final emergent ray and the incident ray. So that is the final emergent ray. You have actually saw this light ray coming out of sphere. You saw this refracted, but actually on sphere that was incident. So real path of light was this. That was the real path. And when you have seen it, it appears to come to you along this path. Here are your eyes. So you are looking at this path, whereas actual path was that. So between the initial ray and between the final ray, the angle made is called deviation. So first we will understand what is deviation. That is the deviation. Okay. After that, if deviation have you got, then we have to calculate this. Tell me one thing, if this angle is I, that angle is R, obviously this angle will be I minus R. And if this angle is R, radius is capital R, radius is capital R, that become beta isosceles triangle. In isosceles triangle, two sides have the same length, so their base angle must be same. Their base angle must be same, right? And if this is I, this is R, this is R, this will be I, obviously. Same pair for the medium. So this angle here will be how much? I minus R. So this interior angle, I minus R. That interior angle, I minus R. But delta, it is like this. Please have a look. This is delta, which is the exterior angle for the triangle ABC. For the triangle ABC, the delta is the exterior angle, and this angle I am saying I minus R, that angle I am saying I minus R, and we all know that exterior angle is sum of two opposite interior angles. From the triangle property, delta will be 2I minus R. I minus R plus I minus R, that will be 2I minus R. In a sphere, that formula you have to memorize. In a spherical refraction, deviation produced is twice of I minus R. Understood? Twice of I minus R means if some question comes like this, have a look. If my question says a light is incident at 60 degree and light is refracted at 15 degree, what is the deviation produced? I will simply write 2 incidence angle minus refracted angle, and that is 45 into 2, deviation will be 90 degree. For NEET type of question, many questions like this have already come in NEET. So these kind of question you will memorize the formula, and always remember in spherical refraction, deviation is angle of incidence minus angle of refraction and twice of it. Now see one by one. First in your mind be very sure what you are looking at. You are looking at deviation. So you should know what is deviation. This is initial light ray going at what angle of incidence I, then it is going, let's say here, what is angle of refraction R, and then it is going here R, then this also R. Why these two are? Because these two lengths are equal. I hope you know this. In isosceles triangle, when sides are equal, their base angles are same. That is your class 10th, class 9th concept. So these two sides are equal, Babu. So these two angles will also have the same value. Moreover, I and R, so this is R, so this will also be I. Now, why this is I? In Snell's law, we will see. When it is going on this path, actual path of light was this. But when I saw coming out of the sphere, what path I observed was this. This path I observed from my eyes. And actual path of this means light has deviated. That deviation is exterior angle, which will be sum of two interior angles. These two cross are two interior angles. So delta will be cross plus cross. What is value of this cross? This cross, see the geometry, total vertical angle is I vertically opposite is I. If total is I, this is R, what will be cross value? I minus R. Similarly, this is also I minus R, and deviation will be 2I minus R. That is the point I described here. Understood now? Already remember this, they make a note out of it. Spherical deviation is twice I minus R, twice of I minus R. Only thing you need is I, and second thing you need is R. Their difference double is called deviation out of sphere in refraction. Chalo, see this one, laws of refraction. Now what is laws of refraction? For this we will discuss. Have a look here. Pay attention to this. Laws of refraction. What are the law that governs refraction? What information regarding refraction we have? First one is like that beta, that was in reflection. That reflection was the same law here. Angle, first law let me write, then angle I will write. What ray are there here? Incident ray, and then we have refracted ray, incident ray, refracted ray, and the third one is normal. All lie in same plane. All lie in same plane, right? So incident ray, refracted ray, all are in same plane. Means this is incident ray, Babu, that is normal, and that is refracted ray. All these lie in same surface, in same plane. They are not out of the plane. Refracted ray is not coming outside the plane or inside the plane. Got it? I minus R is not for mirror also, Yashasvi. There also it is, deviation is pi minus 2I for mirror. That is not there also. Okay? What is the second law? Second law, there is one light ray. Please focus better here. Second law, you might have something new here. In second law, I am saying one light ray is incidenting on this interface. What is the angle here? I. What is the angle of refraction? R1. Then here I am giving you a vertical surface, vertical interface. This is horizontal interface. This is vertical interface. In this vertical interface, if I am drawing normal, the light, this will be the incidence angle. This is incidence angle. Let's say it's any value. Its value is, obviously this is R1. So that is 90 minus R1. This will be 90 minus R1. Right? Then it is refracted, and when it is refracted with normal angle is R2. Then again I am giving you horizontal surface here. In this horizontal surface, this light is falling, and this light is falling, then again here it will be refracted. This is R2, that is R2, that will be 90 minus R2, and then it will be refracted like this. This is the final angle E. This medium here is mu1. This interface is separating medium mu1 to mu2. Then here total medium, this side was mu2, this, and is this side medium, let's say I am giving you mu3 here. Then this is mu3, then lower medium is mu4, and that medium is mu5. First, see the diagram very completely. I am going to tell you something in Snell's law, the second law that you know, mu equal to sin I by sin r. But see the diagram, have a feel. Diagram, have you understood? Let me know. See the Snell's law. Snell's law says that mu into sin theta is constant for one ray. For a certain ray, mu into sin theta will always have the constant value, right? It's not always one ray. I'm not saying one point. Many of us in our lower class, how we know Snell's law, mu1 sin I equal to mu2 sin r1, Snell's law is over. But that's not exactly the Snell's law. Snell's law is for one particular light ray, doesn't matter how many times it gets refracted, at any point the mu and sin theta product will have a constant value. That theta will always be measured with normal. That is very obvious. In reflection also we are measuring angle of light with normal. So that theta angle is measured with normal. Okay. Now see here and focus. Medium I am taking mu1. What medium I have taken? I have taken mu1. In mu1 medium with normal, what angle is given? I. So I will write sin I. That same value will be in mu2. When I am writing mu2 medium, I am writing mu2 here. In mu2 medium with normal, what angle is there? R1. Whether you take here or here, in mu2 medium with normal angle is R1. So I will write sin R1. When I am writing again medium mu3, now see mu3 medium. In mu3 medium here, this is mu3 medium. With normal, what angle I am taking? In mu3 I have not taken, this is being taken in mu4 because mu3 was there. In mu3, let me correct it. Here will be mu3. In mu3 medium, what I am taking with normal? I am taking with normal in mu3 medium angle is R2. This is normal angle R2. So I will write mu3 sin R2. And then if I am writing here mu4, in mu4 medium with normal, what is the angle? E. If I am writing mu4, angle with normal is E. So it is not only beta mu1 sin I equal to mu2 sin R or mu equal to sin I by sin R. That is obviously correct, but you have to understand one certain ray, if one certain ray like lights are coming from star to us and they are undergoing too many times, they are undergoing refraction, diffraction is also there. But in that one light is undergoing 10 times. So every time mu sin theta will have the constant value. Doesn't matter if they are touching each other or not touching each other. Now I know it will come once again, but before that, is that okay? Once again, so I will explain for sure. I'm not expecting my kids to get everything in one go. You are not robot. You have intent to know. There you are winner. You want to know this in 10 times, 20 times. I'm comfortable in 200 times also. Okay. But is this basic come ki okay, mu1 sin I, mu2 sin R or mu is sin I by sin R? That is not only the Snell's law. So once again for all of you, this. See this. One example, one diagram see and try to understand Snell's law in that manner. Ki mu sin theta is constant. What is mu? Refractive index. What is theta? Angle with normal, right? Doesn't matter two light are at the same point. One here, same light ray, different points also, mu sin theta will have same value. Now stop scrolling, no, stop texting there, then only you will understand here for 10 seconds only, okay? 10-second pause everyone. 11 seconds, it's all yours. Again, you can type. One light is going here, that is medium mu1, and I am saying this angle is angle of incidence. Then this light ray is going and that angle is R1. Then here obviously this is R1, alternate interior angle, that is R1 as well, mu2. Now from here suppose light is going somewhere, this is the medium, it is going like this and that is R3. This is mu3. In this with normal, it will obviously make R3 only, right? Then suppose here light is bending here or going like this, and this angle is R4 and this medium is mu4. Now what is Snell's law? Many of the students, many of us know Snell's law at one point. Suppose I will ask you at A. At A I am using Snell's law and you will say it is easy. Mu1 sin I is equal to mu2 sin R1. This much knowledge we have already. What I want you to know supplementarily, it is not at one point, it is for one light ray, not for one point. Can you notice these all are one light ray only? So if I am writing here at B or in medium mu3, I am picking medium mu3. In mu3 medium with normal, what is the angle beta? R3. So mu3 sin R3. And in medium mu1, what is angle with normal? I. So that is mu1 sin I. They will have the same value. Doesn't matter ki these 2 points, point C and point A, they are not at the same point. Still mu sin theta will be constant. So 2 points need not to be at the same point. Just across mu1 sin I, mu2 sin I are not equal. It is equal for all the medium, all the refraction on one light ray. Whether they are touching or they are not touching, all are same. That is the actual Snell's law. Now again you started 590, you got, okay. See, this is the definition. What is Snell's law? There is nothing definition like this. For a certain ray, if you want me to write, I will write that way. For a certain ray, one ray you have to take value, mu sin theta will have a constant value and that is called Snell's law. It is one light ray, not one point only. That little modification you will do in your knowledge and you will be conceptually that clear. Okay, right. Now I am going to discuss one point that I guess many of you must be waiting. Why angle I equal to angle R? Because you would say then I have not discussed it. For one light ray, Snell's law you have got. Now I am going to discuss you one thing. Why angle I equal to angle R? Butterfly, my birthday is on 26th May. You are actually concerned about birthday on 26th May. Not about Snell's. Snell's worked so hard to give a law to you and you are not actually giving him due respect. Okay. Now see this, angle I equal to angle R, and the law is, please everyone pay attention to it, Fermat's principle. Fermat's principle. According to Fermat, when light travels from one point to another, light travels along shortest path. Okay, lights travel along shortest path. When light has to go from one point to another point, light travels through a shortest path. That is the Fermat's principle that we are using in reflection as well as in refraction also. So Fermat principle is what? It is saying that light travels along the shortest path. Let's say I am taking one object here, right? And that object is sending a light ray. That is sending a light ray on this surface. When it's sending a light ray on this surface, here angle is incident angle and that angle is theta 1, right? Then it is reflected from here, and when it is reflected with normal at theta 2. As of now, we don't know theta 1 and theta 2 are equal or not. We have to prove it. Angle I equal to angle R. We don't know, but some angle is there that we know. So that is theta 1 with normal anti-clockwise. This is theta 2 with normal clockwise. Okay. Now let's say that height is h and that distance is x1. That is x2 and that distance on the same level I am taking h, or you can take any level, it will not change it. For simplification I have taken at the same level. This point is A, this point is B. So what is the distance traveled by light? Distance traveled by light will be OAB, that is OA plus AB. That is the distance. That distance I can write by Pythagoras theorem. Please everyone think what is the value of OA. If h is given, x1 is given, how would you write OA? You will write under root h square plus x1 square. Got it? And AB you will write h square plus x2 square. That is this. What is the time? Time is distance divided by speed of light. I am taking here c as speed of light, and from basic kinematics we know this time equal to distance by speed. So speed of light is c. But that time will be least time. If light is traveling, light will travel along a path that is taking the least amount of time, and that time has to be minimum time. And you have done differentiation. In differentiation, anything is minima or anything is maxima, then its rate of change is 0. For minima or maxima, rate of change is 0, dt by dx 0. What is variable here? X. What is variable here? X. So when I will write for minima maxima, derivative is 0, and I am differentiating t, OAB by c, and putting it 0. What is t? T is OAB by c. OAB by c. OAB already I have this. So c is a constant. If I will write differentiation of this, that will be how much? It will be h square plus x1 square, here 2x1. Similarly, that I will write, that will be 2x2. I hope I am relying on your differentiation knowledge for this. That is pure maths, not physics. 2 under root h square plus x2 square, and then I will write here c was also there, and this derivative has to be equal to 0. If I will multiply c to 0, cross multiply anything multiplied to 0 is 0. 2 will be cancelled here, and that x1 by this, x1 by under root h square plus x1 square is minus x2 by under root h square plus x2 square. Now please see for theta 1. For this theta 1, perpendicular is this. For theta 1, that is called perpendicular, and that is equal to x1. And this is under root h square plus x1 square, that is beta hypotenuse. So if I am writing x1 perpendicular by this hypotenuse, it means I have writing perpendicular upon hypotenuse, and perpendicular upon hypotenuse means sine theta 1. And there that will be sine theta 2, and from here theta 1 will be equal to theta 2. It means angle I equal to angle R. You might question me minus. Minus is only saying the opposite sense of measurement. One is clockwise, one is anti-clockwise. So since opposite, that's why minus sign is here. Otherwise, numerical value wise, angle I will be equal to angle R. That is called Fermat's principle. That is little maths. Why it is equal to 0? All subject corner. See, when I say something is maxima, please have to understand, you all have to understand this. Anything is maximum, it means it is a constant value, right? Maximum will always be having a constant value. If 2-3 things are like, who is the eldest brother of you? That answer will be only 1. The maximum is only 1. That is a constant value. And you know that for every constant, differentiation is 0. So maximum, minima are always constant, and their derivative is 0. Differentiation constant 0, that you know. Okay. So just I have given you this basic idea. Maybe you will struggle in this because of differentiation, but one thing you will recall forever. If someone is asking you why angle I equal to angle R, tell it is Fermat's principle. It will take least time, minimum time, and due to symmetry theta 1 equal to theta 2. Okay. See this. One question came, sine, I am writing sine theta 1 equal to sine theta 2. Then actually theta 1 will be n pi plus minus 1 raised to power n into theta 2. If anyone knows maths, that will go like this. Means if you are not aware of this also, then I can say theta 1 will be theta 2, then it will be theta 2 plus 2 pi, then it will be theta 2 plus 4 pi, because after every 2 pi, sine will repeat its values. But the principal value, the least value will be what? Theta 1 equal to theta 2. Just a differentiation. Time for light. Light has a maximum speed, so light will have a minimum time. And for minima, its derivative dt by dx is 0. That is the maths behind it, right? When you are calculating time, that is total distance OAB by C. This is OAB. OAB by C, and OAB was under root x1 square plus h square plus x2 square. Just Pythagoras. we have to write something here, right? लिखना तो है, you have to write to calculate it. This is how it can be proved. This is C, that is the time. But when I'm using this, C will cross multiply to 0 here and it will automatically be 0. Its differentiation will be 1 by 2 root. If you know the differentiation, otherwise you will struggle with this. And nothing to worry about this because you will know differentiation with due course of time. X2 square plus H square, and that will be 2x1 here and that will be 2x2. This becomes, roughly I am writing because already I have written sin theta 1 equal to sin theta 2. Principal value beta will be theta 1 equal to theta 2, the least value. Other values will come, but we are only concerned with the principal value. Basic have you understood? Basic idea have you got? I'm not asking you to be like more talented than Newton in one class, but basic idea, something that you didn't know, now you know. That is evolvement. That is how we evolve every day. If that you know, it's all done. Okay, so in that schedule we are ending it here only. Some basic concept regarding vectors and optics we have done. Next, waiting to see you when you will come here and waiting to learn Telugu from you also. Okay ji, namaste, bye bye, take care.
A very, very good morning to all of you. All right, today we will be studying something very, very new, okay, something magical which you would not have studied before. I think so. Maybe some of you might have studied this one as well, but most of you, I am thinking that you have not studied this particular topic. Yes, chocolate question also I'll give. Today we'll be talking about same mole concept problems a little bit, but in a different manner. Okay. So in the last 3 classes, what you have studied, in the last 4 classes, you have studied about limiting reagent, you have studied about percentage purity related questions. Today also we will see the similar type of questions, but you can solve all those things even without balancing the reaction. Even without balancing the reaction. So if someone feels that balancing is a difficult thing, if sometimes reactions come very complex, then balancing become difficult for you, you can solve the question of stoichiometry without balancing. So it's kind of a magic only. It's kind of a magic only. And the magic is principle of atomic conservation. To solve stoichiometry question, without balancing. Without balancing the equations. Without balancing the equation. Now we are going to study the magic. Magic is called as POAC, Principle of Atomic Conservation. Principle of Atomic Conservation. Okay. So, in case any question comes from the mole concept, from the stoichiometry, there is another way of solving, which is principle of atomic conservation. How do we apply it and what is it? Principle of atomic conservation says nothing but beta, that during a chemical reaction, atoms of all elements remain conserved. Okay, just like you say energy is neither created nor destroyed, in the same way atoms are neither created nor destroyed. So number of atoms will remain conserved. That means atoms of X, any element X on left hand side must be equal to atoms of X on right hand side of the reaction. Without any balancing, I can say that during a reaction, Ravi Teja, Pakila Hanuman, Lahari, please don't talk to yourselves among each other. Okay. All right. So atoms of X on the left hand side must remain equal to atoms of X on the right hand side. This is what we have to do. I'll show you with one example. All of you see here. Example. Okay. If a simple question comes like, find mass of ammonia produced find the mass of ammonia produced by reaction of 5.6 gram nitrogen gas with hydrogen gas. Okay, something like this. I know all of you can solve this question by unitary method. Okay, all of us know unitary method. It's a simple question. Solving by unitary method is also very, very easy here. How do we use the next method, which is POAC? I am showing you here. Okay, all of you see here. If you want to use POAC, don't balance. Just write the reaction. Reaction is nitrogen plus hydrogen gives ammonia. Okay, nitrogen plus hydrogen gives ammonia. I am showing nitrogen with a pink color and I am showing hydrogen with a blue color. Okay, so there are, or hydrogen with a yellow color I'll show. There are two types of atoms here, hydrogen and nitrogen in ammonia. Okay, so you just need to say one thing here, that I will apply POAC for nitrogen. Now, whenever you say POAC means I am trying to conserve atoms. I can conserve nitrogen, I can also conserve hydrogen. I will show you both POAC how to apply. Please see here carefully. Please see here carefully. First I am applying POAC on nitrogen atom. Then I will also show you how to apply POAC on hydrogen atoms. POAC on nitrogen atom, POAC on hydrogen atom. On nitrogen atom, to apply POAC, we'll just say moles of N nitrogen on left hand side equal to moles of nitrogen atom on right hand side. Okay, moles of nitrogen on the left hand side equal to moles of nitrogen on the right hand side. Now, where is nitrogen present? See, nitrogen is present in N2 gas. Nitrogen is present in N2 gas. In each N2, look at the foot. In each N2, how many nitrogen atoms are present? 2 nitrogen atoms. How many nitrogen atoms are present? 2 nitrogen atoms. So I will say left hand side, all the nitrogen atoms are present in N2 and each N2 contain 2 nitrogen. So can I say moles of nitrogen on left hand side is nothing but 2 times moles of nitrogen gas. 2 times moles of nitrogen gas. And on the right hand side, when I go, all the nitrogen is present in ammonia, and look at the foot of nitrogen, there is only 1 nitrogen in ammonia. So I can say moles of nitrogen are nothing but 1 times moles of ammonia. Can I say this? Yes or no? Think about it. Think about it. Where is the nitrogen present? I am saying nitrogen on the left hand side, nitrogen atoms on the left hand side is present in N2. Is present in N2. How many nitrogens are there in N2? 2 nitrogens. So I will say atoms of nitrogen are double of N2. So I will say moles of nitrogen are nothing but 2 times moles of N2 gas. Yes, 2 times moles of N2 gas. And on the right hand side, all the nitrogen is present in ammonia. If I know the moles of ammonia, each ammonia contain 1 nitrogen. So moles of nitrogen on the right hand side will be 1 time moles of ammonia. Is this clear? Yes or no? That's all. Finish. Question is done. Question is over. This is how you apply POAC of nitrogen. Now tell me, how do we apply POAC of hydrogen? Can anybody tell me how to apply POAC of hydrogen? Can anybody write in the chat box and tell me POAC of hydrogen, how do I apply? Keep the hydrogen atoms on left and right hand side same and tell me how the POAC would look like. Whatever nitrogens are there on this side, same amount of nitrogens will be there on this side. Atoms will not go anywhere. Okay. On left hand side, where is N? N is in the N2. N is in the N2. In N2, how many N's are there? 2 N's are there. 2 nitrogens are there. No? So I'll say moles of the nitrogen on left hand side is nothing but double of the moles of N2. And on the right hand side, nitrogen is in ammonia. In each ammonia, there is 1 nitrogen. So if I know the moles of ammonia, I'll multiply it by 1 only, because whatever the moles of ammonia are, same number of nitrogen atoms are there. If there is 1 ammonia, how many nitrogens? 1 nitrogen. If there are 5 ammonia, how many nitrogen? 5 nitrogen. So if I know the moles of ammonia, I'll multiply by 1. Same way POAC of hydrogen. All of you see here again. Left hand side, hydrogen, there are 2 hydrogens in H2. So I will say 2 times moles of H2. These are the hydrogen atoms on the left hand side, 2 times moles of H2. Yes. And on the right hand side, hydrogen, all the hydrogen has gone to ammonia. In each ammonia, how many hydrogens? 3 hydrogens. So I'll say on right hand side, there are 3 hydrogens per ammonia. So 3 times moles of ammonia. If you can do this much, all answers you'll get. Now let us see the question. Question is, find the mass of ammonia. Now they have given nitrogen amount, they are asking ammonia amount. What is common in ammonia and nitrogen? Tell me. Which atom is common in ammonia and nitrogen? Nitrogen. So we'll use the POAC of nitrogen. We will use the POAC of nitrogen. Now this is our nitrogen POAC. Let us use it. Okay. This is our POAC of nitrogen. 2 times moles of N2 equal to 1 times moles of ammonia. 2 times moles of nitrogen gas equal to 1 time moles of ammonia. Moles can be written as weight by molar mass. So I am writing 2 times weight of nitrogen given 5.6 by molar mass of nitrogen 28 gram. Okay, 28 gram. Weight by molar mass equal to 1 time weight of ammonia, which we have to find out, by molar mass of ammonia, which is 17 gram, which is nothing but 17 gram. So we get weight of ammonia produced is nothing but 2 times 5.6 by 28 into 17 into 17. So we get how much? We get 5.65 exactly is 28. So we get 34 upon 5, which is 6.8 grams. That is the answer. 6.8 gram. Symbol of mole, I am using N. Yes, N. N means moles. N means moles. Okay. Tell me, just once it will take 2 minutes to understand. Once you understand, after this, it will become very, very easy. Okay. Is this 6.8 clear? How we have said yes or no? POAC of nitrogen clear to everybody? Yes. So here we just need to use the simple mole formulas. Weight by molar mass. You can write the moles as weight by molar mass. You can write the moles as atoms by Avogadro number. You can write the moles as volume by 22.4 liter. Moles can be written in any of the form. Yes, very easy. Question is like this. Find molecules of water produced by complete combustion of 7.2 gram glucose. Everybody see here. If I had to do it by unitary method, I will have to balance the reaction, which will take a lot of time, hai na? But here what I will do, I will say glucose C6H12O6 will react with oxygen, will give CO2 and H2O. Now can you tell me one thing? What is common between glucose and water? What is common? What is common between glucose and water and completely conserved, not going anywhere else? Hydrogen, all the hydrogen which is present on this side. Can I say this? All the hydrogen has gone to water, yes or no? All the hydrogen has gone to water? Yes. But oxygen I can't say, beta. Oxygen is present here also. 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 So I cannot say that all the oxygen atoms have gone from glucose to water. I can't say. I cannot say this. No. Think about it. Oxygen was present here also, in CO2 also, in H2. How can you say oxygen is conserved between glucose and water? Can I say? Can I say all the oxygen from the glucose has gone into water? I don't know. Maybe some oxygen atoms are going in CO2. Maybe some oxygen atoms are coming from O2. I don't know. Yes. So what is common? Tell me. H. What is common? H is common. O is not common. Yes. So can I conserve hydrogen? Yes or no? Without balancing anything. Can I conserve hydrogen? Yes or no? Yes. So I'll use POAC on hydrogen. Tell me, left hand side, what should I write about hydrogen? Where is hydrogen? Where is hydrogen? Hydrogen is here. How many are there? 12. So moles of glucose, if you know, just multiply it with 12, they become the hydrogen moles. Yes, very good. On the right hand side, all the hydrogen has gone to H2O. If I know the moles of water, I just need to multiply it with 2. Finish. Reaction over. Can I say like this, yes or no? 12 times moles of glucose equal to 2 times moles of water. Now put the formula. Glucose ka they have given mass. So I'll take mass by molar mass. 12 times 7.2 gram by 180 gram molar mass equal to 2 times moles of water. I can say number of molecules by Avogadro number. That's all. Finish. I don't have to balance also. I don't even have to balance also. So I get nothing but molecules of water come out to be molecules of H2O come out to be 12 into 7.2 by 180 into 6 into 10 power 23 by 2. Okay, this 2 has gone down, this thing has gone up. So we get on the table of 2 3s are 360 times 12 5 times. So we get 7.2 by 5, which is nothing but 1.44. So we get 1.44 into 10 to the power 23 molecules of H2O. All right, one more will do. Look at this one. Do you want to try this? Do you want to try this? Quickly try this and do yourself. Molar mass of phosphorus, if anybody wants to know, it's 31 gram. Now tell me, for which atom will you apply POAC? Will you apply it for phosphorus or for oxygen? For which atom? Whenever you are applying POAC, you always apply POAC for an atom, not for a molecule. Yes, P you will apply for. Very good. P you will apply for. Why you will apply for O? P, phosphorus. Yes. Because among phosphorus and among P4O10, P is common, na? Yes. They have given this. They have given this. They are asking this. Among these two, you see what is common. Among these two, phosphorus is common. P is common. Among these two, common part is phosphorus. Common part is phosphorus. Apply POAC on phosphorus, get the answer quickly. I am applying POAC on phosphorus. On left hand side, where is phosphorus? Phosphorus is in the P. They are saying what mass of P4O10 is produced by reaction of 62 grams of phosphorus with excess of oxygen. Okay. So they are giving us P value. They are asking P4O10 ka mass. POAC on phosphorus. On left hand side, all the phosphorus is present in P. And in the P, there is only one phosphorus. There is only one phosphorus atom in a P. So I'll say 1 time moles of P. 1 time moles of P equal to right hand side, all the phosphorus is in P4O10. 4 times moles of P4O10. Arey, what is difficult in this? You tell me. Is it simple or not simple, everybody? 1 time moles of phosphorus. So 1 time weight of phosphorus 62 gram by molar mass of phosphorus 31 gram equal to 4 times weight of P4O10 by molar mass of P4O10. Molar mass of P4O10. What is the molar mass of P4O10? It is 4 phosphorus, means 4 times 31 plus 10 oxygens, 10 times 16. 160 plus 124, which is 284. So I'll divide by 284. Divide by 284. That's all. So weight of P4O10 comes out to be 62 by 31 into 284 by 4. 31 2 times 142 gram is the answer. Shall we do one more? POAC of phosphorus I just applied. You could apply POAC of oxygen as well, but it would not be used here because I did not know the amount of oxygen. If I apply POAC of oxygen, you see here, in O2 oxygen is present 2 atoms. So I can apply POAC of oxygen saying that 2 times moles of oxygen equal to, in P4O10 there are 10 oxygens, 10 times moles of P4O10. If they gave us mass of oxygen, we would have used this. I would have used this. If oxygen was given, I would have used POAC on oxygen. If phosphorus was given, we used POAC on phosphorus. Simple, simple, very simple. Very, very simple. No need to balance. Very, very simple. Now, someone was asking, sir, that could we use it in every question? Answer is no. You can only use it if all the atom is getting conserved completely. If I say, what mass of O2 will react with phosphorus? If I gave you the question, what mass of O2 will react with phosphorus? In that case, I can't conserve them. No. In phosphorus and O2, there is no common atom. So I can't conserve anything here. So here I have to use the unitary method. I have to balance and go. Okay. Yes. So you can use it if there is conservation happening. If there is no conservation happening, in that case, you go for unitary method. Shall we do one more? Let's do one more. Do this one, all of you. We will not balance it. Now what you do is, those whose names start with, those people whose names start with A to K, you do by unitary method. Those whose name starts with A to K, you do by unitary method, everybody. And tell me how much time it took. And those whose names start from L to Z, you do by POAC. You do by POAC. A to K, unitary method, and also type the answer and time. L to Z, whoever is name starting from L to Z. Now, let me do it first by unitary method. If I go by unitary method, I will have to balance the reaction. I will say ammonia plus O2 gives NO plus H2O. Quickly balance. 3 hydrogen, 2 hydrogen. I will make it 3 times. So it became 6 hydrogen. I'll make it 2 times. Became 6 hydrogen. 2 nitrogen, 2 NO. Now oxygen. 2 plus 3, 5 oxygen. So I'll have to do 5 by 2. 5 by 2. So mole concept is 2 mole react with 2.5 mole to give 2 mole and give 3 mole. Okay. So now I'll say 2 mole ammonia gives 2 mole NO. They have given you the mass of ammonia. Everybody, you might have got the answer as wrong because it is milligram given. You took it gram, I don't know why. See the question carefully. It is milligram given. 6.8 milligram is given, not grams. 6.8 milligram. 8.96 ml should come, not 8.96 liter. Okay. 2 mole produce 2 mole. That means I can say 2 times 17 gram ammonia gives 2 times 22.4 liter NO. So 1 gram will produce 2 times 22.4 by 34, and 6.8 milligram means 6.8 into 10 power minus 3 gram is going to produce 2 into 22.4 by 34 into 6.8 into 10 power minus 3. These many liter. Now if I try to cancel out, on the table of 6.8, 5 times exactly 34. So I am getting 44.8 by 5 into 10 power minus 3. 44.8 by 5 into 10 power minus 3 liter, which is coming out to be what you said, 8.96 into 10 power minus 3 liter. This is the answer. 0.0896 is the answer, bache. POAC. Now let's do by POAC. Same thing. Applying the POAC on nitrogen, because I have to go from ammonia to NO. All the nitrogen is conserved. all the nitrogen is conserved. So I'll say ammonia has 1 nitrogen, 1 times moles of ammonia equal to 1 time moles of NO without balancing. 1 time moles of ammonia equal to 1 time moles of NO. Moles of ammonia means 6.8 milligram by 17 gram equal to moles of NO, which is volume of NO by 22.4 liter. Okay, like this. This takes obviously less time. So volume of nitric oxide, you will get it from here 8.96 into 10 power minus 3 liter. I hope you think POAC is easier. Yes. Now balancing the reaction might take a lot of time here. So it's better to use POAC. If you feel that balancing of reaction is easy, use unitary method. If you feel somewhere that there is possibility of using POAC, how do you know the possibility of using POAC? Apply POAC. If everything is known to you, you use it. Otherwise, use unitary method. This is the last question we'll do today. Reaction. Combustion reaction, you should know, bache. Combustion means reaction with O2 to give CO2 plus H2O. Combustion, every day you do at home. One thing I know in combustion, all the hydrogen will go to water. All the carbon will go to CO2. Let us see. What mass of H2O liquid is produced by complete combustion of these many moles of benzoic acid? I don't even have to write the reaction. I know that during combustion, this is the reaction if anybody wants to write. Obviously, balancing will take at least half a minute or 1 minute. So without balancing, I will do. They are talking about benzoic acid and water. What is getting conserved? Oxygen is not getting conserved in between these two molecules, but hydrogen is getting conserved. All the hydrogen on left hand side is present in this compound. Same way on all the hydrogen on the right hand side is present in water. How many hydrogens are there in C6H5COOH? Tell me. In benzoic acid, how many hydrogens are there? 6. Yes. 6. So I am applying POAC on hydrogen. If they asked CO2, you would have applied POAC on carbon. If they asked CO2, all the carbon is conserved. So also write the POAC of carbon yourself. Also write the POAC of carbon yourself. I am solving this question for the hydrogen. So I'll say 6 times moles of benzoic acid equal to right hand side 2 times moles of water. 6 times moles of benzoic acid, 0.35 given. So I don't have to take any molar mass, directly moles only are given, 0.35 equal to 2 times moles of water. I can say moles of water can be written as weight by molar mass. Weight of water by 18 gram. This goes 9 times. So from here weight of H2O comes out to be 6 times 9 times 0.35, which is 54 into 0.35. 54 into 0.35. Okay, 18.9, absolutely correct. 18.9 grams. Very good. Clap for yourself. All right, guys. I hope it is clear to everyone. If it is clear, please write crystal clear. Then we will move on to the next class. It is my last class with you today. So I hope I will see you all again. Will miss you all too. So when you come here, please talk to me and get in touch. Bye bye. Take care.
Hey students, good morning. Okay, today our body topic is fertilization. The meaning for fertilization and mechanism of the fertilization different from plant group to the plant group. In normal fertilization is commonly found in all types of sexually reproducing organisms. Fusion of two gametes is the fertilization. In these two gametes, one is the male gamete, another one is the female gamete. One gamete is the male, another gamete is the female. Fusion of two gametes is fertilization. But whereas in angiosperms, The fertilization is the double fertilization. It is one unique feature or characteristic feature of flowering plants like angiosperms. Double fertilization. Two types of gametic fusions are there in angiosperms. It is the unique for angiosperms only. Angiosperms only this kind of mechanism occurs in the two types of gametic fusions. If only one kind of gametic fusion is there, that is the normal fertilization found in algae, bryophyta members, pteridophyta members and gymnosperms. The name of these two gametic fusions are, one is syngamy, means fusion of gametes. Another gametic fusion is the triple fusion. Another one is the triple fusion. Due to the presence of these two types of gametic fusions in angiosperms, it is called double fertilization. It is present in only angiosperms. Okay. It is about the basic information regarding fertilization. Observe here. After entering one of the synergid, the pollen tube burst. After entering the pollen tube into one of the synergid, the pollen tube burst and release the two male gametes into synergids. I will draw one diagram here. Identify it is the diagram of the structure. Guess. It is the half of the portion of embryo sac towards a micropylar area. One egg cell is present. What are the cells are present either sides of the egg? Synergids. One synergid and another synergid cell. Synergid. Two synergids on one egg together called egg apparatus. Egg apparatus. It is the synergid nucleus. Synergid nucleus. What is the characteristic feature of synergid? In that one, some finger-like projections are present. It is called filiform apparatus. Here also, filiform apparatus is there. Filiform apparatus. Filiform apparatus. Presence of filiform apparatus is the characteristic feature or identical character of a synergid cell. Two synergids are present at the size of the egg in egg apparatus. The place of egg apparatus always close towards the micropylar region of ovule. It is the outer integument of ovule. It is the enlarged sector diagram of ovule with an embryo sac. Now, what is the cell is found inside of the embryo sac, a largest cell of embryo sac? Entire this portion is called as a central cell. In that central cell, two nuclei are present. The name of each and every nucleus is haploid polar nuclei. The cells are called haploid polar nuclei. Now, tell me once again, what is the place of this embryo sac? Embryo sac generally found in ovule. Ovule with micropylar region, chalaza and funiculus. Inside of this ovule, an embryo sac is there. In embryo sac, egg is always placed towards the micropylar region of the ovule. These kind of ovules are found inside of ovary. It is ovary. Style, stigma. Stigma, style, ovary, intra-ovarian cavity or locule, ovule and embryo sac with three types of cells and three antipodals and one central cell with two polar nuclei. It is a 7-celled, 8-nucleated embryo sac. So, among these four structures, carpel, ovary, ovule, embryo sac, which one is the bigger? What is the biggest structure among these four? Carpel, ovary, ovule, embryo sac. Here the biggest structure is the carpel. Second place goes to ovary. Third place goes to ovule. Next place goes to embryo sac. Smallest structure is the egg. Smallest. First one carpel. The basal swollen part of the carpel is called as the ovary. Inside of ovary, one to many ovules are present. Each ovule possesses female gametophyte. Other name of the female gametophyte is embryo sac. Finally, ultimately, only one egg is present in each embryo sac or each ovule. In each ovule, number of embryo sac only one. So hence, number of eggs in each ovule, single egg present in each ovule. Okay, na? Carpel, it is the level of organization. Next to the carpel, ovary is there. Next to the ovary, ovules. After that, embryo sac and eggs are present. What are the structures are landed on stigmatic area? With the help of the pollination, pollen grains land on stigma. The stigmatic secretions are helpful for germination of pollen grain. Pollen germination means formation of pollen tube. Formation of pollen tube. Pollen tube finally enter into an embryo sac through the micropylar region. Micropylar is the one of the gateway for entry of pollen tube into embryo sac. Okay, no? Micropylar area is the one of the gateway for entry of pollen tube into one of the synergid cell. Final destination point of pollen tube is synergid. Identify the elaborated diagram. It is the pollen tube. The entry of pollen tube or elongation of pollen tube guided by chemicals are released from filiform apparatus of the synergid. The chemicals can guide the pathway of the pollen tube, and that can receive, synergid cell receive a pollen tube. This entire structure is the pollen tube. What are the structures are found inside of the pollen tube? 2 sperms and 1 vegetative cell is there. Maximum number of cells in pollen tube 3. Maximum number of cells in this pollen tube 3. One is the vegetative cell, remaining 2 are sperms. When pollen tube enter into synergid cell, then terminal region of the tube burst and both the male gametes discharge into synergid cell. It is the releasing of male gametes into synergid. So the purpose of pollen tube is sperm carrier or male gamete carrier into the synergid cell. So functioning of the synergid cell is it can direct the pollen tube entry and receive both the male gametes from pollen tube into it. Tell me, what kind of growth or movements exhibited by the pollen tube? What kind of growth or movements exhibited by pollen tube, not grain, pollen tube? Elongation or extension of pollen tube towards the chemicals. By attracting these chemicals, it can grow towards the filiform apparatus area or synergid area. And the movements of pollen tube or growth of the pollen tube is called chemotactic movements. Chemotactic. Tactic by attracting chemicals released from synergid cell. Pollen tube can grow towards that area, and there such kind of movements of the pollen tube are called chemotactic movements. Chemotactic, chemo, representative of the chemical secretions. Tactic, attracting. Or that movement also called as the chemotropism. One more name of it is the chemotropism. That phenomena is the chemotropism. The movement of pollen tube is the chemotactic. Finally here, how many male gametes discharge into synergid cell? 2 male gametes. In out of 2 male gamete, 1 male gamete able to migrate into egg cell and finally fuse with egg nuclei. It is the syngamy. Tell me once again, what is the meaning for the syngamy? fusion of one male gamete nuclei with the egg nucleus. That pink color one is the egg nucleus or female nuclei. That green color one is the male nuclei or sperm nuclei. This fusion takes place inside of the egg cell. This kind of fusion is called as the syngamy. Fusion of two gametes is the syngamy. What about the second male gamete nucleus? Second male gamete nucleus gradually move out from or away from the synergid cell and finally fuses with nuclei of central cell. This entire area is the central cell. Biggest cell of an embryo sac is the central cell. In central cell, it has the two haploid polar nuclei. Just before the triple fusion, both the haploid polar nucleus are united with each other, and this polar nuclei become as the secondary nucleus. Secondary nucleus. Tell me once again, how does the diploid secondary nucleus is formed? How does the secondary nucleus is formed? By the fusion of two haploid polar nuclei, one diploid secondary nucleus is formed. That secondary nucleus only eligible to fuse with haploid sperm. One sperm already involved in syngamy, second sperm of the same pollen tube. Actually, both the sperms are the twins of the pollen tube. These two are the twins. In this twin, one is engaged with egg nucleus, second is engaged with secondary nucleus. How does the secondary nucleus is formed? By the fusion of two polar nuclei, one secondary nucleus is formed. The ploidy of the secondary nucleus is the 2n condition. Ploidy of the egg is the n condition. Total how many genomes or sets of the chromosomes participate in this fusion? Total 3. Total 3. 2 from secondary nucleus or female parent, 1 from male parental male nucleus. Total 3 types of nucleus are involved in fusion. Hence, it is named as the triple fusion. Triple fusion. One kind of gametic fusion is the syngamy, takes place in egg. Second kind of gametic fusion is the triple fusion. To the presence of these two types of gametic fusion, this entire process is called as the double fertilization. Double fertilization. Observe here. One of the male gametes moves towards the egg cell and fuses with the egg nucleus. It is the syngamy. Then result of the syngamy is the zygote. Syngamy leads to the formation of diploid zygote. Observe this equation. One male gamete nucleus fuses with the egg nucleus. Both the gametes are in haploid condition, n plus n. N plus n, and give rise to diploid zygote. Diploid zygote is the result of syngamy. Okay. Here the two types of genomes are contributed. Genome. What is genome? A single set of chromosomes is also called as genomes. All genes present in one set of chromosomes is the genome. N is the representative symbol for each genome. Female cells, male cells, both are involved in fertilization. Female contribution, egg and central cell for double fertilization. These two are contributions from female parent. From male parent, sperm. How many sperms obtained from each pollen tube? 2 sperms. 1 sperm engaged with the egg. Second sperm engaged with the central cell. Central cell. Fusion of the haploid egg nucleus with haploid sperm is the syngamy, and finally you can get diploid zygote. So in zygote, out of 2 genomes, one contributed from female parent or maternal, another from paternal parent. Whereas in triple fusion, the diploid central cell contributes a pair of genomes, 2 genomes. only one genome is contributed from paternal parent. Finally, a resultant cell is the primary endosperm nucleus. Short name PEN. What is the full form of the PEN? Primary endosperm nucleus. The ploidy of primary endosperm nucleus, triploid. What is the source for this triploid nucleus or three genomes? Tell me. What is the source of the three genomes are found in PEN, primary endosperm nucleus? Two genomes contributed from female parent. One genome, nothing but one set of chromosomes contributed from male parent in the form of sperm. Finally, how many genomes are involved in this kind of gametic fusion? 3, hence it is named as the triple fusion. Triple fusion. The name of the first kind of gametic fusion is the syngamy. Syngamy and triple fusion together called double fertilization is the unique feature of angiosperms. Some model questions here. Listen carefully. Try to give answers for these questions. How many genomes are participated in syngamy? For the total number of genomes or sets of chromosomes are participate in syngamy. Two genomes, one from female parent, another from male parent. Total number of genomes are 2. Whereas in triple fusion, total number of genomes, in triple fusion, okay. In syngamy, 2 correct. What about the types of number of genomes involved in triple fusion? Yes, 3. In the 3, the ratio of maternal and paternal genomes, maternal 2, paternal 1, total 3 genomes are there. It is about the 3 genomic condition of PEN. Finally, we can conclude total how many female genomes are maternal genomes? Maternal, mother. Genomes are required for double fertilization. 2 plus 1, 3 genomes. 2 from central cell, 1 from egg cell, total 3 genomes. From male side or paternal side, total number of genomes involved here, 2 genomes in the form of 2 sperms. It is a double fertilization. Finally, 5 genomes involvement is there. We can ask the 6 questions here. It is one of the area to construct 6 questions. So, listen one by one. First question, concentrate. Total how many genomes involved in syngamy? Answer, 2 genomes. Second question, total how many genomes involved in triple fusion? Answer, 3 genomes. Total number of genomes involved in triple fusion, 3 genomes. Question number 3. What is the ratio of maternal and paternal genomes involved in syngamy? Ratio of maternal and paternal genomes, 1:1 in case of syngamy. Okay. Likewise, what is the ratio of maternal and paternal genomes in triple fusion? In case of syngamy, maternal-paternal genomic ratio is the 1:1. Whereas in triple fusion, what is the ratio of maternal and paternal genomes? 2:1. Okay, in syngamy, 1:1, triple fusion, 2:1. In double fertilization, final question, last 6th question. What is the ratio of maternal genomes to the paternal genomes in overall double fertilization? Overall double fertilization. Yes, good. 3:2. 3:2. If the answer is the 1:1, then what is the question? Ratio of maternal paternal genomes in syngamy. If the answer is the 2:1, then question is what is the ratio of maternal and paternal genomes in triple fusion? Okay. If the answer is the 3:2, then question is what is the ratio of maternal and paternal genomes in overall double fertilization? 3:2. Finally, 3 genomes contributed from female parent, only 2 genomes contributed from male parent to get double fertilization or to form 5N condition. Zygote is in 2N condition, pen in 3 condition, total 2 plus 3, 5. So contribution from the mother side is greater than that of the father side in double fertilization program. Contribution of the female is the greater than that of male contribution in double fertilization of angiosperms. It is a detailed account of double fertilization in angio. In pollen tube, 2 gametes are there. Second gamete fuses with the secondary nucleus. Second nucleus is a pair of polar nuclei together called secondary nucleus. Polar nuclei of the both the polar nucleus. To form primary endosome nucleus, short name of the primary endosome nucleus is pen. This fusion also called as the triple fusion, because total 3 genomes or 3 nuclei takes place in this fusion. Now identify this video. Transferring of pollen from one flower to another flower, pollen falling and pollination. Germination of pollen tube. Within the pollen tube, 2 nuclei are there earlier, one is the vegetative, another one male gametes. Final destination point of that pollen tube is an embryo sac. In cross pollination, pollen transfer from one flower to another flower. If the pollination takes place in 2 flowers, that is the xenogamy. Germination of pollen grain is outer exine, inner intine give rise to pollen tube. Pollen tube. The stigmatic secretions can recognize that pollen and decide that pollen is the right pollen or wrong pollen. Observe here, in out of 2 cells, one is the vegetative cell, second generative cell. Only the second generative cell is the division capable. Second cell is the division capable, give rise to 2 male gametes. So name the cell that is the mother for gametes, generative cell. 2 generative. Finally, total number of cells in this pollen tube, 3 cells. Pollen tube acts as a sperm carrier. Finally, enter into one of the synergid cell. It will enter into one of the synergid. Micropylar area is one of the area for entry of pollen tube. Pollen tube receiving structure is the synergid. Synergid cell. Pollen tube carries both the male gametes. Discharging of one male gamete into synergid finally reaches to egg. And the blue colored one is the male gamete fused with egg cell, give rise to diploid nucleus. The name of the diploid cell is the zygote. Syngamy completed here. What about the second male gamete? Once again, observe here. One of the male gamete gradually migrate and finally enter into egg. For the purpose of syngamy. Second male gamete enter into central cell. Central cell has the 2 polar nuclei and fused with the second nucleus to form primary endosome nucleus. It is the mechanism of double fertilization in an embryo sac. Now, once observe this diagram here, total number of cells in this embryo sac. Total number of cells, not nucleus, 7. Total number of nucleus. Okay, cell number 7, nucleus number 8. 1, 2, 3, 4, 5, 6, 7, 8. Within the single central cell, 2 nucleus are there. Yes, 8 nuclei. In this, out of 7 cells, how many cells directly participate in double fertilization? Out of 7, among these 7, how many cells directly participate in double fertilization? Only 2. One is the egg, another one is the central cell. What about remaining 4 cells, 5 cells? 3 antipodals degenerates either before or after fertilization. There is no any kind of role for these antipodals in the double fertilization. One of the synergid can receive the pollen tube. Second synergid may degenerate. That's why finally we can say 3 antipodals, 2 synergids not directly involved in double fertilization. 5 degenerated out of 7. Only 2 cells are involved in direct fertilization. One is the egg for syngamy, central cell for triple fusion. This concept already completed. Male gamete nucleus plus secondary nucleus or central cell give rise to primary endosome nucleus. This kind of gametic fusion is the syngamy, triple fusion. N plus 2n give rise to 3n. Then the ploidy of primary endosome nucleus is the 3n condition. Since 2 types of fusion, syngamy and triple fusion takes place in embryo sac, that phenomenon is termed as double fertilization. This event occurs in only angiosomes, nothing but flowering plants. Specific character or peculiar character of angiosomes. Total how many number of nuclei participate in double fertilization? 5. 2 from male parent, 3 from female parent. Try to answer these questions. Filiform apparator is found in. Filiform apparator is found in. Answer. Synergid. Yes, first option. What is the functioning of this filiform apparator? The chemical secretions of the filiform apparator can guide the entry of pollen tube, journey of the pollen tube, entry of the pollen tube in embryo sac decided by or regulated by the chemical secretions of synergid. Next question. The entry of pollen tube into embryo sac is under the guidance of chemotropic, chemotactic, phototropic, thigmotropic. Entry of pollen tube into an embryo sac is under the guidance of chemotropic. That process is the chemotropic, but the movement of pollen tube is called chemotactic. Both are slightly variable. Pollen tube movement is the chemo, that phenomena or process is the chemotropic, or also called as the chemotropism. Next, pollination by animals is called, you learn in last class, pollination by animal. Pollination by the animals. Study of animals, zoology, so zoophily. What about the anemophily? Anemo, wind pollination. Wind pollination. What is the hydrophily? Is the pollen transferring agent in the water? Hydrophily. What is the entomophily? Study of insects, entomology. Study of insects, entomology. That's why if the insects are the pollen transferring agent, that kind of pollination or such flowers are called entomophily. The pollination flowers are entomophilous. Entomophily is the kind of zoophily. Entomophily is the type of zoophily. Next question. The pollination takes place by bats. The pollination takes place by bats. Chiropterophily. What is the meaning for ornithophily? Study of birds, ornithology. Study of birds, ornithology. Is the body is agent for pollination, ornithology. Study of snails, malacology. If the male is the pollen transferring, snail is the pollen transferring agent, then such flowers are malacophilous. The name of that pollination in malacophilous flowers is malacophily. Ophiophily, snakes. The pollen transferring agent is snake. Fusion of male gamete with polar nuclei. One of the two polar nuclei in embryo sac is known as fusion of one male gamete with polar nuclei present in central cell of an embryo sac is triple fusion. Triple fusion. No. First option not one. Double fertilization means both the syngamy and triple fusion together called double fertilization. If the polar nucleus is clearly mentioned, that's why you have to go to the triple fusion only. Yes, fourth option. Next, accession region question. Accession region. Double fertilization is the characteristic feature of angiosperms or flowering plants. Is it true or false? Statement is true. Second reason, the occurrence of two fertilizations or two types of gametic fusions within the same embryo sac is called double fertilization. Then what is the proper answer? First option is right answer. First option is right answer. Accession, reason both are correct, and reason correct explanation for accession. It is the characteristic feature or unique feature of all angiosperms. So first one is the true. Next, endosome of the following plants develop from. Endosome of the flowering plants develop from haplonucleus or diploid or triploid or tetraploid. Triploid nucleus. As a result of triple fusion, penny is formed. Primary endosome nucleus. The primary endosome nucleus is the first cell for the development of endosperm. First cell of endosperm. Then the ploidy of endosome is the 3N. Next question. End products of the sexual reproduction. Final ultimate end products of the sexual reproduction. Inflorescence, flowers, fruits and seeds, or all of the above. Answer for this question. Yes, fruits and seeds only. Inflorescence, flowers are helpful for sexual reproduction, but end products of the reproduction, fruit and seeds, are the fertilization. Ovary become as a fruit and ovule become as a seed. As the botanist once gave the definition for the fruit. What is the definition for the fruit? Fertilized ovary is the fruit. As a botanist, you have to give answer for this question. Fertilized ovary is fruit. Fertilized ovule is seed. Seeds are fertilized ovules or ripened ovules. Definition for fruit is fertilized ovary or ripened ovaries. Yes. After fertilization, some kind of changes occurs in flowers. Observe the diagram. The stalk of the flower is the pedicel. Swollen tip of the pedicel is the thalamus. In the thalamus, 4 types of floral whorls are present. One is the calyx with sepals. Second one is the corolla with petals. Third whorl, stamens and androecium. Last whorl, gynoecium with carpels. In every carpel, 3 pods are there. Ovary, style, stigma. After fertilization, only one structure is the remaining, all are fall down. Except one structure. What is the structure is the remnant in this flower after fertilization? Is it sepal or petal or stamen or entire carpel or just only part of the carpel, ovary? Except ovary, remaining all are withered or fall down. Sepals fall down, petals also fall down, stamens fall down. In carpel, style and stigma withered or degenerates. Ovary is the remnant structure or persistent structure. Persistent, permanently attached one. Name the part of the flower that is the persistent even after the fertilization. Ovary. Now, what are the structures found inside of the ovary? Ovules. Ovules also persistent. As a result of fertilization, ovules become as seeds, ovary into fruit. Due to the presence of ovules in ovary, seeds found inside of the fruit. Seeds found inside of the fruit. Okay, these are the some of the post fertilization changes in a flower. So I will ask one general knowledge question. Try to give answer for that question. Name the plant. Listen the question. Name the plant in that calyx is the persistent along with the ovary. Except calyx and ovary, remaining all floral organs are fall down. Name the plant in that calyx is the persistent. Calyx also remains along with the fruit. Name the plant. Try to give answer for that question. I will give some options. One is rose, second hibiscus, scientific name of the China rose hibiscus, third brinjal, fourth one banana. What is the right answer? Question is the persistent calyx is found in. Persistent means permanently attached calyx. Generally 99% of the flowering plants calyx sepals fall down after fertilization. But in one plant, among these four, one plant, calyx is the persistent. Rose, wrong answer. Banana also wrong answer. By eliminating these two, only one is remained here, that is the brinjal. Observe the brinjal fruit diagram. This is the stalk of the fruit or stalk of the flower pedicel. Brinjal fruit. Sepals permanently attached with this fruit. Fruit brinjal. Name this green color portion of the fruit. Persistent calyx. Ovary already persistent, no doubt. In all fruit giving plants, ovary is the persistent permanently occurs. Especially in brinjal, tomato, chilli, and datura also, calyx is the persistent, permanent attached. In some kind of family members like Asteraceae members. Asteraceae members. It is a small reduced fruit. On the top of the fruit, white color tuft-like hair, bunch of hairs are present. This is also calyx, modified calyx into these hairy structures for the dispersal of fruit from one place to another place. You might have seen in summer season, along with the wind currents, some small black color seeds are dispersed like a parachute with the help of this persistent calyx. You might have seen a white tuft of hair carry small seeds. So the purpose of calyx in this kind of plants, fruit dispersal for the geographical distribution of their species, to spread their species throughout the world. Fruit dispersal or seed dispersal essential. That seed dispersal is carried out by persistent calyx. Is one of the functioning or advantage of presence of persistent calyx in Asteraceae family members. Like sunflower members, chrysanthemum and marigold plants. Persistent calyx is there. The mechanism of fruit dispersal is like a parachute mechanism. This persistent calyx acts as a parachute to carry fruits from one place to another place with the help of the wind. Okay, I will explain post fertilization changes occurs in flower in next class. Okay, bye Nana, bye Ra.
Hello dear students, how are you all? So let us start our today's class, and I'll just tell you what we did in the last class. So in the last class we did the muscle, right? Muscular tissue. We did the muscular tissue. Muscular tissue forms the muscle muscle, right? I have told you 40 to 50% of your body weight is contributed by your muscles, right? So we have seen muscular tissue is mesodermal in origin. We have seen 3 different types of muscles. We have seen the structure of muscle. That muscle is made up of muscle bundles. Yes. You are showing me your biceps, huh? I can't see your biceps. All right, everyone. So, muscles are of 3 different types, and muscle structure we have seen. So, in the muscle structure, muscle is made up of muscle bundle. Every muscle bundle is made up of muscle fibers, right? So many muscle fibers are there, and muscle fiber is considered as a muscle cell. So cells are making the tissue, just like that. Muscle fiber is the cell which is making the muscular tissue. Okay, let's start today's class. And in today's class, we are going to study the last tissue, the last type of tissue, beta, that is nervous tissue. Nervous tissue. So I know that you people are not at all nervous, है ना? You people are not at all nervous. You people are excited. You people are not nervous. But we will study the nervous tissue. All right. So nervous tissue is, beta, you know the origin. First of all, tell me the origin of the nervous tissue. Yes, I have told you the origin of nervous tissue. Ectodermal origin, ectoderm. But I will tell you one exception here. In this ectoderm origin, I will tell you one exception. Okay, let me just go ahead and then I will tell you. Okay, first of all, the ectoderm is the origin, and then very important property. Very important property. Beta, this is the property which is also present in the muscular tissue. So there is one property which is common in between muscular tissue and nervous tissue. Can you tell me which is that property? Excitability. Excitability is the property. Very important property, beta. Excitability. It is the property of the nervous tissue as well as of the muscular tissue. Nervous tissue and muscular tissue. Your muscles can also receive the impulse, can also receive the stimulus and generate the impulse, just like your neurons. Your neurons are also excitable cells. Okay, so origin is ectoderm, property is excitability. Now I will tell you what are the cells of the nervous tissue. Nervous tissue is made up of or it consists of beta two types of cells. It consists of neurons, and it consists of neuroglial cells. It consists of neuroglial cells. Right? So these are the two types of cells which are forming this nervous tissue. Our nervous tissue is forming the nervous system, beta. Okay. So neurons and neuroglial cells. Neurons and neuroglial cells. Neurons are the excitable cells. If somebody will ask you which of the cells are excitable cells, because of that cells only it has excitability. So neurons are the excitable cells, beta. Neurons are the excitable cells. Neurons are the excitable cells. Excitable cells means they will receive the stimulus. They are always ready to receive the stimulus. They are excited, just like you people. You people are always excited. Yes, for the class. For the class, you people are excited. Just like that, excitable cells, they receive stimulus. They receive stimulus and give response. So the main function is done by the neurons, beta. The main function is done by the neurons only. But what is the use of neuroglial cells then? And do you know one thing? Neurons are excitable cell, but neuroglial cells are more than neurons. Yes, everyone, very important line of NCERT. Neuroglial cells are more than neurons. Neuroglial cells make up more than 50% of the volume of nervous tissue. So neuroglial cells, they are present around the neurons. They are present around the neurons. They support the neurons, right? They are present around the neurons. They support the neurons. They support the neurons. And very important line. They make up more than half more than 50% or more than half of the nervous tissue. More than half of the nervous tissue. More than half of the nervous tissue is formed by, more than half of the nervous tissue is formed by neuroglial cells. Very, very important line of NCERT. Very important. Now, coming to neuroglial cells further, they are of two types, beta. These neuroglial cells further are of two types. Some are small in size, small, micro, and some are macro. Please concentrate on the lecture. Don't talk. When I am asking question, then only you should tell the answer. Otherwise, you should simply listen to the lecture and understand. Try to understand, beta. You are here to study, hai na? You are here to study, not for the time pass. Yes, Mallikarjun. Yes, you are the neurons, you are always excited. But I am the neuroglial cell, I am always supporting you. Hai na? I am always supporting you to study. Okay, so two types of neuroglial cells are there. One are the small, they are known as microglial cells. Microglial cells. And the other is the large, they are known as macroglial cells. Micro means small and macro means large. Micro means small and macro means large. These microglial cells, beta, they are nothing but they are macrophages. Now, what is a macrophage? What is Venkat? Please have patience, beta. I will tell you what is a Schwann cell. I will tell you what is a Schwann cell. This is a neuroglial cell only. I will come to that. Have patience. So, microglial cells are macrophages. What are macrophages? Tell me. Microglial cells are macrophages only. Macrophages of the nervous tissue are known as microglial cells. They are present in your central nervous system, in your peripheral nervous system, right? So, macrophage is WBC. Phagocytosis, exactly, very good, Vasant. Phagocytosis. So, phagocytosis, macrophages type of WBC, beta. Which type of WBC? Monocyte. I have told you monocyte. Monocyte only becomes macrophage when it enters into the tissue. When it is present in the blood, it is monocyte. See, in the blood, formed elements are there. In the formed elements, RBC is there, WBC is there, platelets are there. In the WBC, so many types of WBCs are there. Neutrophil, basophil, eosinophil, monocyte, lymphocyte. Yes, just like a song, hai na? So, monocytes. I have told you monocytes. Now, these monocytes are present in the bloodstream. When they will migrate to the tissue, then they will become macrophage. They will become huge. They will eat. They will do phagocytosis, right? So, macrophage is a WBC. Now, you tell me WBC is a blood cell. Blood is a connective tissue. Connective tissue is mesodermal in origin. But nervous tissue is ectodermal in origin. So, what is the exception? What is the exception? Now you got it. Now you got it. What is the exception? So, this microglial cell is the exception because it is a WBC. WBC is a blood cell. Blood cell is a connective tissue. Connective tissue is mesodermal in origin. So, microglial cell also is a mesodermal in origin. So, can I write there? Can I write ectoderm except? Can I write except microglial cell? Yes or no? Can I write microglial cell? Yes or no, everyone? Exception is microglial cell. Alright, understood microglial cells. Now coming to the macroglial cells. Macroglial cells are of 4 different types. We will not go into much detail, but I will tell you the important things. One name is astrocyte, star shaped. Astrocytes are there. One name is oligodendrocyte. One name is oligodendrocyte. One name is ependymal cell. One name is ependymal cell, ependymal cells, and the another name Schwann cell, Schwann cells. Okay, so these are the different types of macroglial cells, beta, macroglial cells. This is microglial cell, this is macroglial cell. There are no further types of microglial cell, but there are 4 different types of macroglial cells. Okay. Now all these cells, all these, thank you beta, thank you Viber. So all these cells are present in the nervous system, in your central nervous system, in your peripheral nervous system. But there are some differences. If you see these 3 cells, astrocytes, oligodendrocytes, ependymal cells, they are present in your central nervous system. And Schwann cell is the cell which is not present in central nervous system, it is present in peripheral nervous system. I will tell you what is the difference between central nervous system and peripheral nervous system. Okay? I will tell you the difference between CNS and PNS. I will tell you, I will come to it. I will come to it. So I hope this much is clear. I hope this much is clear. Okay, now if somebody will ask you microglial cells are present in CNS or PNS, then what you will tell? In both. Microglial cells are present in both. They are present in both. They are present in CNS as well as PNS. Both. They are present in CNS and PNS both, beta. Now I will tell you what is CNS, what is PNS. You understood about the cells. Cells only are forming the tissue. So this is our nervous tissue. Nervous tissue has neurons and neuroglial cells. Which cells are more? Neuroglial cells are more than neurons, right? Then neuroglial cells are of different types. One is small, microglial. One is big, macroglial. Macroglial has different types: astrocyte, oligodendrocyte, ependymal cells and Schwann cells. So you should not remember all the cells, but you should definitely remember the 2 names. These 2 names you should definitely remember. One is oligodendrocyte and one is Schwann cell. Very, very important function they have. They have a very important function, that is the formation of myelin sheath. Formation of myelin sheath. They both will do the same function, that is formation of myelin sheath, beta. Formation of myelin sheath. Do you know what is a myelin sheath? I will discuss structure of neuron with you. So in the structure of neuron, I will tell you what is a myelin sheath. Sometimes myelin sheath is there, sometimes it is not there. When it is present, the neuron is myelinated. When it is not present, the neuron is unmyelinated. Okay. So if somebody will ask you myelin sheath formation, which cell is doing myelin sheath formation in central nervous system? Oligodendrocyte. Which cell is doing myelin sheath formation in peripheral nervous system? Schwann cell. Schwann cell. Should remember everything basic and important information I am giving you. Very, very important information. Okay, very important information. Yes, yes. So many of you know about the about the myelin sheath. Yes, very good. Very good. Okay. Now let me tell you about the nervous system. About the nervous system. Okay. Let me come to the nervous system, beta. Nervous system. So nervous tissue is forming what? It forms your nervous system. Yet, yes or no? It forms your nervous system. Just like muscular tissue is forming your muscles, right? Just like that, neural tissue or nervous tissue is forming your nervous system. Without this nervous system, you cannot do anything. Nervous tissue has the greatest control over your body's responsiveness. How you respond to me, how I respond to you, that is all because of our nervous tissue. Alright everyone, our nervous tissue. So now Nervous tissue is forming the nervous system. Nervous system is of two types, beta. Nervous system is of two types. Central nervous system, CNS. Peripheral nervous system, PNS. Let me write the full form also, otherwise you will tell madam is writing only in short. Central nervous system. PNS means peripheral nervous system. Peripheral nervous system. Peripheral means periphery. Center means center. Central means in the center. In the center you have a brain inside your head. Here you have a brain. Then in the vertebral column you have a backbone, right? At the back you have a backbone. So that backbone is known as vertebral column. Let us suppose this is your vertebral column. So from the vertebral column, spinal cord is passed like this. Spinal cord is passing through the vertebral column. So brain and spinal cord forms the central nervous system. Central nervous system has brain and spinal cord, because these two things are coming in the center, beta. Center. Brain and spinal cord in the center. We are not going to see the details of brain and spinal cord here. There is a different chapter for that. And that different chapter is neural control and coordination chapter. That is a chapter of human physiology. Once you come here, we will study. Okay. Now peripheral nervous system. So beta, peripheral nervous system consists of what? Can anybody tell me peripheral nervous system consists of what? Yes. So some answers are coming already. Nerves. Have you heard of nerves? I will tell you today how a nerve is formed. Okay. So peripheral nervous system consists of nerves. It consists of what, beta? It consists of nerves. And these nerves, they are arising either from brain or spinal cord. Some of the nerves are arising from the brain and they are going to different parts of your body. And some of the nerves are arising from the spinal cord and they are also going to different parts of your body. Okay. So, two types of nerves will be there, arising from brain, cranial nerves, arising from spinal cord, spinal nerves, arising from spinal cord, spinal nerves. So, two types of nerves are there, cranial nerves and spinal nerves. Bhavna, beta, we will talk about CNS in detail, brain, four lobes, everything in the another chapter, not here. Okay. So just stick to the topic. Understand what I am talking, right? What I am talking about is only nervous tissue. Nervous tissue, two types of cells, neurons, neuroglial cells, right? Then nervous tissue forms the nervous system. Nervous system is CNS and PNS. CNS consists of brain and spinal cord. PNS consists of nerves. Nerves can arise from brain. Nerves can arise from spinal cord. So, cranial nerves, spinal nerves. Now these nerves are going into the different organs. And we have two types of organs. The organs which we can control. What are the organs which we can control? What are the organs which we can control? Voluntary, skeletal muscle. Skeletal muscles are the voluntary muscle, beta. So, wherever in any organ, wherever skeletal muscles are present, that organ is voluntary. My hand is voluntary. Yes, I can move it like this. My head is voluntary. Yes, I can move it like this. My legs are voluntary. Yes, I can move my place. I can move from one place to another place. Yes or no? So, whatever organs where skeletal muscles are there, they are voluntary organs, beta. And the nerves which are going to voluntary organs, they make one part of the nervous system. So, let me come. Can I go ahead? Can I move ahead? You must have understood this much. Yes or no? So, let me now move ahead and let me now tell you. See, I have told you nervous system. Nervous system is of two types, central nervous system and peripheral nervous system. So now I am going to talk about peripheral nervous system, which has nerves. I will tell you what are nerves, how they are formed, I will tell you. But some of the nerves from here, they are going to the voluntary parts, beta. Those nerves are forming which system? Somatic nervous system. Somatic nervous system. So somatic nervous system is formed by which nerves? The nerves, the cranial nerves, the spinal nerves, which are going to voluntary parts. So somatic nervous system, nerves innervate, it is formed by the nerves innervate means goes to, innervates means goes to. Nerves innervates voluntary parts of the body, voluntary parts. Understood? Understood somatic nervous system, everyone? Somatic nervous system, are you understanding? Somatic nervous system is formed by those nerves which are going to voluntary parts. Then the another part is autonomic nervous system, beta. Autonomic nervous system. Autonomic nervous system. Right? Autonomic nervous system. Involuntary parts, not in your control. Involuntary parts, not in your control, right? That means there are so many organs which are not in our control, like our internal organs. You cannot control your stomach, na? You cannot tell your stomach, okay, you digest first protein, then you digest the carbohydrate. No, the digestion of carbohydrate will be done first, right? So, like it depends upon the stomach. It depends upon the internal physiology, how it works. So your liver, you cannot tell you make more bile juice, I am getting less bile juice. No, you cannot tell your liver that, right? So you cannot control your internal organs, beta. You cannot control your heart. Yes. So the nerves which are going to heart, the nerves which are going to stomach, the nerves which are going to kidney, liver, pancreas, like any internal organ which is not in our control. Okay, those nerves are forming which system? Autonomic nervous system. Autonomic nervous system. So autonomic nervous system consists of those nerves innervates. Innervates means goes to, innervates involuntary parts. Involuntary parts. Now, in your involuntary parts, two types of functions will be occurring. In your involuntary parts, two types of functions will be occurring. Two types of function. Let us take the example of stomach again. You have eaten, right? You have eaten. Now the food has to be digested. Okay. So for that digestion, your stomach needs to secrete the gastric juice, na? So there should be stimulation of the secretion of gastric juice. Gastric juice should be secreted. So the signal will go and tell the stomach, beta, stomach, now food has come, you have to secrete gastric juice. Now, the stomach has done its work. Digestion of food is done. Now the food, the digested food went to the intestine for further digestion and absorption, right? It went to the intestine. Now your stomach is empty. There's no food in the stomach. So now there should be inhibition of the secretion of gastric juice. Gastric juice will not keep on secreting, right? Now there should be stop. We will tell, our nervous system will tell the stomach, you stop secreting gastric juice. Now there's no food in the stomach. Are you understanding? Yes, everyone. Are you understanding? So there are two types of functions. One is stimulatory function, one is inhibitory function. Every organ is doing, every involuntary organ requires two types of function. One is stimulatory, one is inhibitory. Sometimes our heart needs to, beat fast. So our cardiac activity should be more. So at that time, different nervous system will work. But sometimes our heartbeat needs to be slow, right? So different nervous system will work. For that, for the two different functions, we have two parts of the autonomic nervous system. One is beta sympathetic, one is beta sympathetic, and another is parasympathetic. Another is parasympathetic. So sympathetic nervous system and parasympathetic nervous system, both will do the opposite function. Both will do the opposite function. They both will not do the same function, beta. Both will do the opposite function. That is why, let me write, they both are antagonistic to each other. They both are antagonistic. Antagonistic means opposite. Antagonistic means opposite to each other. Opposite to each other. If one is stimulatory, other will be inhibitory. For different organs, it will be different. For example, let me tell you the example of the cardiac activity. Cardiac activity is stimulated by sympathetic, inhibited by parasympathetic. But in case of your digestive tract, secretion of gastric juices is stimulated by parasympathetic, inhibited by sympathetic. So that means it is not like stimulatory, the sympathetic will be stimulatory always. No. At some parts in the body, at some internal organs, sympathetic can be stimulatory, parasympathetic can be inhibitory. But whereas sometimes in any other different part, parasympathetic can be stimulatory and the sympathetic can be inhibitory. I hope this is clear. Yes or no, everyone? I don't know what you people are talking about. I don't know whether you are listening to the lecture or not, but I have done my work. So now tell me quickly, those who are listening to me, those who are not talking among themselves, tell me, have you understood? Have you understood? Yes, Rohit, Charvik, Bhavna, all of you have understood. Yes, beta, yes. Okay. Now let us move ahead. So you understood this. Now I am going to tell you the nerve. Yes, I told you I will tell you what is a nerve. So let me tell you a nerve. Okay, nerve. Shall I move ahead now? Okay, so we have talked about the neuron. So do you know that, I hope you know the structure of neuron. I hope you know the structure of neuron, but you don't know about the nerve. So let me tell you the nerve. So neuron has two parts. One is the cell body. Also known as cyton or also known as soma. Another is the cell processes, beta. Cell processes. And these cell processes are of two types. One is an axon. And the other is dendrites. Right? So, roughly, I will draw this diagram roughly. This is the cell body. This is the cell body. These are the dendrites which now I am forming. These are the dendrites, beta. Okay. So this is the cell body, beta. From the cell body, you can see the dendrites. Dendrites are coming out. These are dendrites. These are dendrites, beta. These are dendrites. Okay. These are dendrites. And now you can see the axon. This is the axon. And the axon has a terminal. Beta. The axon has a terminal. So, this is the end of the axon. These are the ends of the axon. So this is the axon terminal. this is axon, and this is the cell body. This is the cell body, beta. This is the cell body or cyton. From the cyton, you can see dendrites are arising and dendrites are branched. And this is the axon. Inside the axon, there is exoplasm. This is exoplasm. So, this is a long process known as axon. And inside the axon, there is exoplasm. Inside the axon, there is exoplasm. And this is the axon terminal. This is the axon terminal. Axon terminal. All right. Now, I have told you myelin sheath. Myelin sheath can be there, myelin sheath cannot be there. If myelin sheath will be there, then this neuron will be myelinated. So, but now I have not made the myelin sheath. So, can we tell that this neuron is unmyelinated, beta? Yes, can we tell that this neuron is unmyelinated? This is unmyelinated neuron. But now I will make myelin sheath here. I will make a myelin sheath here. So you can see myelin sheath. I am making the myelin sheath. Now this is the myelin sheath. Okay, this is the myelin sheath I am making. This is the myelin sheath. This is the myelin sheath, beta. So I have made the myelin sheath here. Myelin sheath. Right? I have made the myelin sheath. This is the myelin sheath. So now this neuron will be a myelinated neuron, and there are some places where the myelin sheath is not there. Those places will be called as what? This is axon, this is exoplasm, this is myelin sheath. Yes or no? This is myelin sheath. This is myelin sheath. So there are some places where myelin sheath is not there. That is nodes of Ranvier. Yes, absolutely correct. Node of Ranvier. Node of Ranvier. This is node of Ranvier, beta. Now I will tell you, there is one cell I have told you na, one cell, Schwann cell. That Schwann cell is wrapped around the neurons of PNS, because Schwann cell is present in the some people are saying nodes of Ranveer Singh. Wah beta wah. Nice, nice, nice. Ranveer Singh. Okay. Okay. Schwann cell I have told you. Schwann cell is present in around the neurons of PNS. Let us consider that this is the neuron of PNS. So here you will find Schwann cell also. So I am going to show you the Schwann cell. Let us suppose this is the nucleus of the Schwann cell. This is also the nucleus. Many Schwann cells are present, beta. Many Schwann cells. Many Schwann cells are present, and this is the nucleus of the Schwann cell. So there is the outermost covering of the Schwann cell that is known as neurilemma. That is known as what? Neurilemma. So what is this? This is beta neurilemma. This is neurilemma. Neurilemma. So always remember, neurilemma is the outermost covering of Schwann cell, and Schwann cell is present in only PNS. So neurilemma is also present in only PNS. You will not find neurilemma around the neurons of CNS. You will only see the neurilemma around the neurons of PNS. You will not see the neurilemma around the neurons of CNS. So this is the neuron. So now the last thing of today's class, last thing is nerve. I told you I will tell you nerve. I told you that I will tell you nerve. So remember, this axon has another name, that is a nerve fiber. This is a nerve fiber, beta. Just like muscles are formed by muscle fibers, nerve is formed by nerve fiber. And what is that nerve fiber? Axon. So what is a nerve? What is a nerve? Can we write here nerve? Nerve is collection of or group of axons or group of nerve fibers, in very important. You will not find nerve in CNS, brain and spinal cord. You will find nerve in PNS. So I have told you now already. See, look here. I have already told you. PNS consists of nerves. So these nerves are formed by the axons of neurons. Nerve is a collection of axon or nerve fibers in PNS. Very important. So that was all about, that was the most of the things I have covered in the nervous tissue, and the brief introduction of the nervous system also I have given you. Alright. So now that was all for today's class. I hope you have understood all these things. Just go through the notes once again. If you find any difficulty in understanding anything, we can always clarify it later. So that was all. That was the end of the today's class. See you tomorrow. Tomorrow, I will tell you the topic tomorrow. You will be communicated about the topic tomorrow. Alright. But animal tissues is over. Right? Animal tissues is over. Okay. So bye. See you tomorrow then. And like the session. Okay. Don't forget to like the session. I know you like me, so you will definitely like the session. So subscribe the channel and like the session. Bye bye. Bye bye my lovely kids. See you tomorrow.